Hey guys, welcome to this course of Core Java brought to you by Mikado Solutions. I'm Sanjay Makija and I'm going to take you through this course. Guys, as you know, Java is Object-Oriented Programming Language, OOP. So my first session will be by default devoted towards object-oriented programming. If I ask you, what is the core thing? What's the core thing that we do when it comes to object-oriented programming? Just think, what's the core thing that we do? You know, any object-oriented programming language is used to write applications, software. And we build applications, we develop applications for something which is today happening manually. Today, something is happening manually and I need to computerize it. I need to write a software for it. And for writing a software, I'll use a programming language. Even before I start writing the software, I'll first analyze the things which are today happening manually. During analysis, when at the back of my mind, I know I'm going to use object-oriented programming language to write a software for it. So during analysis, I'm going to focus on two things. One, which are the real world objects which are participating to achieve this thing, which is today happening manually. Today, this thing is happening manually. And to achieve it, there are some real world objects which are participating. My first job is to identify those real world objects. Second, these real world objects, they are interacting with each other. My second job is to identify how are they interacting, because this is exactly what I'm supposed to do in my software. Those real world objects, I'll model them as software objects in my application, and I'm going to make them interact with each other exactly the same way as they are interacting in real world. So as things are happening in real world, they'll start happening in software world. So the core thing, if you look at it, what we are doing when it comes to OOP, we model real world objects as software objects. That is the core thing that we do. Now, since that is the core thing that we do, let me put it. We model real world objects and or abstract entities into software objects. That's the core thing that we do. Real world objects. You know what is a real world object? I am a real world object. You are a real world object. A car is a real world object. A computer is a real world object. But are you aware what is an abstract entity? Because not only real world objects are modeled into software objects, but also abstract entities are modeled as software objects. What is an abstract entity? Abstract, if you go and see dictionary meaning, Oxford, existing in theory, not practically. I give you an example of an abstract entity. Mikado Solutions. We are an IT staffing, training, and consulting company. We have a staffing department, we have a training department, we have a consulting department. If you come to our office, you will see me, a real world object moving around. You'll see a computer, a real world object in my office. But you won't be able to see anything like training department moving around, anything like consulting department moving around. Then what are these? These are abstract entities. Not only do we model real world object into software objects, but we also model abstract entities, a department object. So that's the core thing that we do when it comes to OOP. We model real world objects and or abstract entities into software objects. Now, since this is the core thing that we are supposed to do, there are two questions which come up, which need to be answered. You know which two questions? The first one, what is there? What is there in a real world object which we are supposed to model in a software object? What is there? What has to be modeled? And second, how it has to be modeled. What has to be modeled? How it has to be modeled. So let's try to understand. Let's try to answer these questions. What is there in a real world object that we are supposed to model in a software object, and how to model it? So see here, any real world object has two characteristics. It has two characteristics, state and behaviors. And these are the two characteristics which we are supposed to model in a software object. So whenever you decide to model a real world object into a software object, you try to figure out what makes up its state, what are its behaviors, because these are the two characteristics which you are supposed to model in a software object. State. I don't know whether you've ever realized. I don't know whether you have ever realized, but it's something to realize that whenever you talk about state of a real world object, it will always be with respect to time. It will always be with respect to time. I give you an example. Let's take a car, a real world object. Let's say it's being driven. It's being driven at a particular moment. At a particular moment. How will you define its state? Something like this. Gear is fourth, clutch is released, brake is released, accelerator is pressed, speed is 90 kilometers per hour. That is how you will define the state of that car. But the state that you defined is at that moment, The next moment, the speed may change out to be 95. It may change out to be 85. So whenever you talk about state of an object, it will always be with respect to time. Remember this. Similarly, any real world object exhibits various behaviors. I am a real world object. I am behaving currently. I am teaching you. You are a real world object. You are learning. A car is a real world object. It exhibits various behaviors. Started, stopped, accelerating, decelerating, different behaviors. So these are the two characteristics, state and behaviors, which we are supposed to model in a software object. Now the question comes, how to model? How to model? It's very simple. State is modeled as data and behaviors are modeled as methods. State is modeled as data. Behaviors are modeled as methods. Now let's say I want to model a real world car into a software object. How will I do it? I will model its state as data, something like this. Have a look at the screen, something like this. Int, gear, speed, boolean, clutch, brake, accelerator. State will be modeled as data. Int, gear, speed, boolean, clutch, brake, accelerator. Now look at these. Gear, speed, clutch, brake, accelerator. In syntactical terms, in technical terms, what are they? They are variables. They are variables. And you know, these variables will hold values. These variables will hold values. The values that these variables hold, the values that these variables hold at a particular runtime moment will define the state of your software car at that runtime moment. The values in these variables at any given runtime moment will define the state of your software car at that runtime moment. Again, the values in these variables keep on changing from runtime moment to runtime moment. So here also, when you're talking about state of your software car, it again is with respect to time, runtime, isn't it? So I'm just trying to show you the similarity between real world and software world. In real world also, when you talk about state of a real world object, it's with respect to time. Software objects also, when you talk about state, it is also with respect to time, runtime. Any real world object exhibits behaviors. Behaviors are modeled as methods. Okay, a car. We are trying to model a car. Car exhibits various behaviors. Started, stopped, accelerating, decelerating. So these will be put as methods in this object. Something like this. Public void start, public void stop, public void accelerate. Behaviors are modeled as methods. Again come to real world. Again come to real world. Now tell me, have you ever realized in real world objects, to exhibit any behavior, to exhibit a behavior, we manipulate the state. We manipulate the state so as to exhibit that behavior. Car, how do you start it? You will put gear into one. You will release the brake. You will release the clutch. You will press the accelerator. That is how you will start. So what are you doing? Aren't you manipulating the state? You are manipulating the state so as to exhibit the behavior. That's exactly what you're going to do in these methods. You're going to manipulate the state so as to exhibit that behavior. For example, the start. How will you start the car? How will you start the car? You will tell gear is equal to 1, speed is equal to 10. So what are you doing? Aren't you manipulating the state so as to exhibit that behavior? Similarly, stop. speed is equal to 0. Accelerate, speed is equal to I. You're manipulating the state so as to exhibit that behavior. So exactly as you do it in real world, you're doing it in software world. Again, come to real world. In real world, just think, in real world, can we have isolated objects? Permanently isolated objects? Is it feasible? Is it possible? No. If I am isolated from the world permanently, what I'll do? I'll die. If there is an isolated car, if there is no driver, nothing, no one to drive, it's gone. You're going to lose its engines. They're going to fail. Okay. So real world objects, if you look at it, cannot be permanently isolated. In real world, objects cannot be permanently isolated. In real world, objects coexist. Not only do they coexist, they interact with each other. Real world objects cannot be isolated. Real world objects coexist. Not only do they coexist, they interact with each other. And you know, this interaction happens through a medium. And what we call that medium, we call it interface. Interface. Do you believe this? So I just now talked about some of the points in real world. In real world, objects cannot be isolated. In real world, objects coexist. Not only do they coexist, they interact with each other. And this interaction happens through a medium. Which medium? Interface. Now again, talking about interface, there are very two important things to realize about interface. There are very two important things that you need to realize about interface. One thing about interfaces is such, interfaces are such, they need to be known by one, implemented by the other. Known by one, implemented by other. If I want to interact with you, it has to be through an interface. One of us has to know it, the other guy has to implement it. One has to know, other has to implement. In fact, the rule is, if I want to interact with you, I should know the interface. You should implement it. The one who wants to interact should know, and the other guy should implement it. Now, if you're wondering, what am I saying? I'll give you some example. I interact with AC through remote. What is that remote? Interface. I interact with air conditioner through remote. What is that remote? It's an interface. I should know the interface. AC should implement. I just told you, the one who wants to interact, since I am interacting, so I should know the interface. AC should implement. I know that on that remote, that orange button that I have, if I press it, AC ons. That is knowing. But when I press that orange button, how is AC really getting on is implementation, which air conditioner is doing. Isn't it? So I should know the interface, AC should implement it. That's exactly what is happening. I know that if I click that orange button, AC ons. That is knowing. Imagine if I don't know, can I on the AC? No, I cannot interact. I won't be able to on the AC. I know that when I press the orange button, AC ons. That is knowing. But when I press that orange button, how is AC really turning on is implementation, which AC is doing. I can give you another example. I interact, not only I, even you, interact with computer through keyboard. So what is a keyboard? It's an interface. Again, I should know, computer should implement. I know when I press K on keyboard, K comes on console. I know it. But when I press K on keyboard, how is K really coming on console is implementation, which computer is doing it. So I hope you got the point. Two objects interact with each other through interface. One has to know, other has to implement. Okay. That is one thing about interfaces. The second thing about interfaces is interfaces are generally standardized. They are generally standardized. Now, what do I mean by standardization? I have a 110 AC, Samsung 5-star 110 AC. I also have a Samsung 2-ton 5-star AC. The remote for both of them remains the same. That is what is standardization. The remote control for both of them remains the same. Okay. Another example, we have different, let's say Samsung. We have different Samsung smartphones, different models, but charger remains the same. Why? Because where you plug in the charger is an interface. Interface is same. Implementation might be different, but interface remains the same. That is the meaning of interfaces are generally standardized. Okay. So if you look at these things, they are very much true in real world. I repeat all the things which I just told you about real world. In real world, objects cannot be isolated. In real world, objects coexist. Not only do they coexist, they interact with each other. And this interaction happens through interface. Then I told you two things about interfaces. One, interfaces are such that they need to be known by one, implemented by other. In fact, the rule is the object who wants to interact should know, and the other object should implement. So that is one thing about interfaces. And the second thing about interfaces is they are generally standardized. Interfaces are generally standardized. Okay. Now, all these things which are true in real world, they have to be true in software world also. When it comes to object-oriented programming, that's the beauty of OOP. It totally mirrors real world. So whatever is true in real world has to be true in software world. So in software also, software objects, isolated, do not make sense. In software also, software objects coexist. Not only do they coexist, they interact with each other. And here also, that interaction happens through interface. Okay. Now to explain you better, let's consider I am a real world object. Even I can model myself as a software object. Just imagine if I model myself as a software object, a part of other characteristics which I have, let's forget about it. One of my behaviors is I can drive, I can drive, I can drive. And behaviors are modeled as methods. So don't you think that behavior, drive behavior of mine will be modeled as a method in this object? Yes, something like public void drive. But now for me to drive a car, don't you think I'll have to interact with the car? I'll have to interact with the car. Yes, I'll have to interact with the car. Now these are software objects. So I as a software object will have a reference to that car as a software object, something like this, X. Now don't you think for me to drive a car, how will I drive? I'll have to interact with the car. So first, you guess. That has to be through an interface. I should know it. Car should implement it. Now, what is that interface? What is that interface? What is the interface? You know, when I ask my students, what is the interface? What is the interface? Some students answer me these methods. Some tell me these variables. Some tell me both of them. But no, you know what's the real answer? What is an interface? Set of declaration of methods. Set of public void start, public void stop, public void accelerate. Set of declaration of methods is what is an interface. Not the entire methods, only declaration of methods. The body given to those methods is implementation of the interface. I want to interact with the car. How will I interact? Don't you think I'm going to call these methods? I'll call start method, I'll call stop method, I'll call accelerate method, and that is how I'm going to interact. Now to call a method, I should know the interface. Now to call a method, don't you think I should know the method signature? What is the name of the method? What is the parameter type? What is the return type? What the method does? I am least bothered about how it is doing. How it is doing is implementation. The body given to this method is implementation, which car is doing. I should know the interface. I should know the method signature. Now, how will I interact? Something like this. I'm going to call start method. Look on the screen. If you see x.start, I'm going to call that method. x.accelerate. That is how I'm going to call. So don't you think for me to, I should know the interface. For me to call the method, I should know the method signature. I should know the name of the method. I should know the parameter type. I should know the return type. I should know what the method is doing. I'm least bothered about how it is doing. How it is doing is implementation, which car is doing. So the set of declaration of methods is what is an interface to an object. That makes up interface to any object. Because how do you interact with any object? By calling methods. So those set of declaration of methods is what is an interface. Now coming to variables, why they are not the part of interface. To be honest to you, in our case, even these variables, they are part of interface because they are as good as public. That's why if they are as good as public, so I from outside can touch this car object through that variable. So it's a part of interface. But now, if you keep a variable to be public, anyone from outside can access the value of that variable. He can also assign a value to that variable. Now, in our case, these variables are as good as public. So I from outside, let's say we talk about speed variable. I can access the value of that speed variable as well as I can assign something like this. Int I is equal to x dot speed. So what I'm doing, I'm accessing. Similarly, I can also assign x dot speed is equal to 100. I'm assigning the value to it. I can access as well as I can assign. Now, most of the times what happens, we want someone to access it from outside, but we don't want someone to assign a value to it. But if we keep it public, someone from outside, he'll be able to access as well as he will be able to assign a value to it. So you know what ideal OOP tells you? Ideal OOP tells you never to keep your data public. Always keep it private. Always keep it private. That's what ideal OOP tells you. So let's say we keep this speed private. Okay. Now the moment I keep it private, now from outside, neither will I be able to access nor will I be able to assign a value to it. But the thing is, you actually want someone to access. Yeah, you don't want someone to assign a value to it, but you want someone to access. But by keeping it private, nobody will be able to access, nobody will be able to assign. So listen what OOP tells you, ideal OOP. Ideal OOP tells you, keep your data private. You want someone to access. What you do, you give a public interface to the private data. You give a public interface to the private data. So what you can do in this car, you can give a method, let's say get speed, something like this. Okay, something like this. Public return type int, name of the get method get speed. Look at that method, what it's doing, return speed. Now, don't you think if someone wants to access, like I want to access the speed, what I can do, I can call this method x dot get speed. Now, when I call that x dot get speed, it's going to return me the value of speed. So that way I'll be able to access it. So that's what ideal OOP tells you. Keep the data private and you provide a public interface to the private data. Okay. Keep the data private. Now, considering ideal OOP, data will always be private. If data is always private, we will not, or we don't consider that data, that variables as a part of interface, because someone from outside will not be able to touch the object through that data. That's why it is not the part of interface. So what is an interface to an object? Set of declaration of methods is what is an interface. In fact, let me be more clear. Instead of saying set of declaration of methods, I'll better prefer to say set of declaration of public methods is what is an interface to an object. Set of declaration of public methods. See, if there is any method which is private, nobody can call it from outside. If nobody can call it from outside, it is not a part of interface. So what is an interface to an object? Set of declaration of public methods. Data as per ideal OOP, they'll always be kept private. In fact, you know, ideal OOP, what it tells you, it goes one step ahead. What it tells you, even if your data is unimportant, you want someone to access it as well as you want someone to assign a value to it. You want to allow both the operations. You want someone to access a value of it, a value of that variable, as well as you want someone to assign a value to it. Then also ideal OOP tells you to keep it private and you provide two methods. Okay. Provide two methods. Get speed and maybe a method set speed. If you look at this method set speed, what it is doing, okay, what it is doing, speed is equal to k. Speed is equal to k. It is assigning. This method is being used to assign a value to speed variable. So keep the data private, give two methods, one to access, one to assign. Now, if you are wondering that if I want to allow both the things, I want someone to access as well as I want someone to assign, then why should I keep it private and give two public methods? Why not better keep it public only? That's a better idea. Why to go for all this? So now listen, if ideal OOP is telling you it is something for your good, imagine if you keep that speed variable public, if you keep it public, then I from outside will be able to access, as well as I'll be able to assign a value to it. Now let's say I assign from outside, I assign a value to that speed variable, something like this: x dot speed is equal to minus 100, negative value. Now when you see this, oh man, what is he doing? He's assigning a negative value to my variable. How can speed be negative? Now you are in trouble. You cannot allow this. But then what can you do? You can't do anything. This car is yours. You have authority on your code. But that code, my code, no, you don't have an authority. You cannot come to my code and change that minus 100 to plus 100 or something. You can't do it. Now you are in trouble. You are in trouble. And there will be many people like me who from outside will assign negative values to your speed variable. That won't be accepted. So it would have been better that instead of keeping that variable public, you would have kept it private, and you would have given these two methods, get speed, set speed. Now, if I want to assign a value in such case, where you have kept the variable private and you have given two methods, in such case, if I want to assign a value to your variable, I'm going to call set speed method, something like this. If you see here, x dot set speed 50, x dot set speed 50. Now, if I want to assign a negative value, x dot set speed inside the bracket minus 100. Now I'm assigning a negative value. Now you don't have to worry. If this is what I'm doing, you can always put a check. What you can do inside this set speed method, you can just write a if condition. If k greater than or equal to 0, speed is equal to k, or else nothing. So that way you can validate. You can have a future control over your data. So it's always advisable and recommended by ideal OOP that you should always keep your data private, and you should give methods, one to access, one to assign. Okay, if you want to allow both. Later, you can always have restrictions on it. You can put validations, and you will have a control over it. Okay, so going as per ideal OOP, our data will always be private. Always be private. So we don't consider data to be part of an interface. So what we consider, once again I repeat, what we consider interface to an object, set of declaration of public methods is what is an interface, because those are the methods through which outside world interacts with your object by calling those methods. So set of declaration of public methods is what is an interface. The body given to that is implementation of the interface. In me and car, I want to interact with the car. I should know the interface. I should know the method signature. I should know the name of the method. I should know the parameter type. I should know the return type. I should know what the method is doing. How it is doing is implementation, which car is doing. So anyway, here the message was, just like in real world, I told you some things about real world. Real world objects isolated do not make sense. Real world objects coexist. Not only do they coexist, they interact with each other. And this interaction happens through interface. Two things about interface. Interfaces are such, one has to know, other has to implement. In fact, the rule is the object who wants to interact should know, and the other guy should implement. Okay. And the second thing about interfaces are generally standardized. Whatever is true in real world has to be true in software world also. So in software also, software also, isolated objects do not make sense. In software also, objects coexist. Not only do they coexist, they interact with each other. And this interaction here also happens through an interface. One has to know, other has to implement. As per the rule, the object who wants to interact should know, and the other object should implement. Here, I wanted to interact with the car, so I should know the interface, car should implement it. We identified what is that interface. This set of declaration of methods, public void start, declaration of methods is what is an interface. I should know the interface. I should know the method signature. I should know the name of the method. I should know the parameter type. I should know the return type. I should know what the method is doing. How it is doing is implementation, which car is doing. For me to interact with the car, I'm going to call these methods, and to call these methods, I should know the signature of the methods. So that's about interface. I hope you saw the similarity. So this was about object. Now how I'd like to show you how graphically object is represented. How are objects represented graphically? This is how objects are represented graphically. If you see here, the nucleus made up of data, speed, gear, brake, clutch, accelerator. Nucleus made up of data surrounded by methods, surrounded by methods. You know what we say? The data is secured within the secured custody of methods. If any other object wants to access the data, it has to go through these methods. It has to go through this interface. Then only he can access data. So data is secured within the secured custody of method. Any other object wants to access it, it has to go through these methods. So this is how graphically object is represented. So this was a short discussion on object. In our next session, we will talk about class. So we'll meet in the next session. Bye for now.